Hello, my dear students. Welcome to lecture 2, Metals and Non-Metals. In this particular lecture, we will deal with other type of chemical reactions and we will deal with the reactivity series. And in the last, if we talk about that, what we have studied in the last lecture. So in the last lecture, we have dealt with metals, non-metals, what is metal, what is non-metal, and how they are different from each other. Similarly, when we talk about the reaction of the metals with acid, reaction of the metals with oxygen, reaction of the metal with the water. So we have understood about this type of reactions. Now let's understand that there is a special fact related to the aluminum foil that when we talk about the aluminum foil is generally used to wrap the food. For example, if we are having any tiffin and we wants to take the food in the tiffin, then we generally do the we use aluminum foil. Okay, similarly aluminum foil is also used to some other type of substances in food as well. So that is the general case, that is generally a very famous use of the aluminum foil, but it is not good for our health because aluminum can react with the oxygen in presence of the heat, and there is formation of the alumina, and that alumina is not good for our health, because in that case what will happen, it will go into our body and it will surely is dangerous, not instant dangerous, but it is a slow poison, you can say. Okay, so what happens when we talk about the aluminum foil? Aluminum react with the oxygen in presence of the heat and makes the alumina, and that alumina is not good for our health. Okay, so this is why we aluminum foil not to be used. It should not be used. Okay, there has to be another like a replacement of this because it is not good for our health. Similarly, when we are making the food in the aluminum vessels, that is also not good because it react with the aluminum react with the oxygen and forms the aluminum. Okay, now let's talk about a fun fact that anodizing is a process. When we talk about the anodizing, when we are having any vessel, we have having any anode there, we are having cathode there, we have connected it to the cell. So let's understand the statement here that anodizing is a process of forming a thick oxide layer of aluminum. Aluminum develops a thin oxide layer when exposed to the air. Okay, that's what we are talking about, that aluminum react with the oxygen and makes the alumina. It makes a thin layer of the oxide which is known as the alumina. Okay. The aluminum oxide coat makes it resistant to the further corrosion, and it can be used to uh, stop the corrosion because it is a high oxidizing. Oxidation of the aluminum is very easy. It very readily oxidizes. Okay, and the resistance can be improved further by making the oxide layer thicker. And if you want to make the corrode resistance the vessel or the any other part, so you can make the thick layer as well of the oxide. During anodizing, a clean aluminum article is made the anode and electrolyzed with dilute sulfuric acid. Okay, the oxygen gas evolved at the anode react with the aluminum to make let's understand what is happening here. For example, we are having a electrolyte that is H2SO4, that is H2SO4, dilute H2SO4. Okay, that is also thing. And we are having any substance. Here is the anode, here is the cathode, and they are connected with the cell. And we put a substance and we will put the aluminum foil and aluminum substance here. So what will happen here? There will be oxidation of the here at the anode. This is anode and this is cathode. It is having positive charge, it is having negative charge. So there is aqueous solution, means there will be H plus and there will be OH minus. So OH minus will go, that anion that will go in direction of the positive charge of the anode. So there will be release of the oxygen gas. That's what we are talking about, that uh, oxygen gas is evolved at the anode. That's what we are talking about. But you can think that, sir, here two types of the ions are possible. OH minus is possible, SO4 2 minus is possible. But when we talk about the discharge potential of the sulfate ion and the discharge potential of the OH minus ion, that OH minus ion has the less discharge potential, means it will go fastly then the SO4 2 minus toward the anode. So discharge potential is the factor when we are talking about more than one cation or more than one anion. Okay. And when we talk about the H plus, so H plus hydrogen gas will be released there. But if there is aluminium, so aluminium will basically that will the aluminum 3 plus will convert into the aluminium. Okay, so that will be formation of a layer. A layer will be formed of the aluminium like this, and this process is known as the anodizing. Okay, this process is actually known as the anodizing, and this oxide layer can be dyed easily to give aluminum article an attractive finish. It can be also makes the any substance attractive because it is having kind of sign, so that is good as well. Okay, okay. So these are the fun fact related that is generally used to make the uh, layer of the alumina. Okay, now when we talk about the reactivity series, so we are starting the reactivity series, and you have to understand the reactivity series very well, because this reactivity series is very much important in chemistry, not only in this particular chapter but in the higher classes as well. So what does the reactivity series tells about us? There is a series in which the elements are arranged in the decreasing order or the increasing order of their reactivity. So for example, if we are going from the potassium to the potassium to the platinum, so we are going up to the down. So in that case, what will happen? There will be decrease in the reactivity series. Reactivity will decrease of the elements. So when we are going from the potassium from to the platinum, so there will be decrease in the reactivity, and potassium is the most reactive element and the platinum is the less reactive element. Gold, platinum, silver, these are the less reactive element. You can see this particular fact with the reactivity series. But how you will remember this particular series? So there is a new mnemonic. Please stop calling me a cute zebra. Okay. Instead, say how. Say learning how can Selena make gold and platinum. So what is the mnemonic? Please stop calling me a cute zebra. Instead, say learning how can Selena make gold and platinum. So this is how you can remember the reactivity series. So let's try to decode. For example, from the please you can make potassium. From stop you can make sodium, that is Na. From calling you can make calcium. From the me you can make magnesium, and from A you can make aluminium, from cute you can make carbon, and from zebra you can make zinc, and from instead you can make iron, from say you can make tin, from learning you can make lead, from how you can make H, from can you can make copper, okay, Selena you make silver, from gold you already know AU, and this is platinum. So this is how you can remember the reactivity series. And this reactivity series is widely used in the chemistry to understand the reactivity of the element. When we were studying the displacement reactions, we were comparing some reactions that, for example, if we are having copper sulfate solution and I put a iron nail in that particular solution, what will happen? The blue color of the solution will become light, that become fade, and that is because of the reactivity theory. That is because of the reactivity of the copper and the iron. When we compare the reactivity